Okay, so thank you everyone for joining in, and I'm sure we'll have more as we go on. Session 4 of the SPL Masterclasses, and today it's all about headphone amps and the Matrix. And to do this and to host this event, we're very happy to have Mr. Raghav Somani, as you can see, with a bunch of headphones at the back. He's the founder and CEO of the Headphone Zone. All of you guys who are into headphones must know this place. He's a fantastic guy. He knows his shit. He knows every little thing about headphones. If you have any doubt about headphones, that's the man you need to talk to. And we are happy to have him host today's event with Xavier and Hermann. Xavier is the vice president of SPL sales, and we have the co-founder and partner of SPL, Mr. Hermann Gier, also with us, who will be taking us through the session for the day. So without any further ado, let me pass the session on to Raghav. Raghav, all yours. Go for it.
Wishing everybody over here a happy holiday season. And I can see a lot of you guys are joining in today from home and from work. Namaste, Vanakkam, hello to everybody over here. So I'm very excited about today's session because, of course, headphone amplifiers and headphones itself is a part of what I do every day. It's part of my everyday routine, and I love listening to music on headphones. I think it's the only way to listen to music, really. Today we're going to be talking about SPL's range of products that really are meant for headphone listeners, both in the studio and at home. And it's a lot of fun to be able to talk to the co-founder, Hermann himself, because unlike a lot of other brands who don't really have a story behind the products or a why behind the products beyond it makes us good money, it's a great opportunity to talk about why the co-founders developed the products and the thought process and the science behind it. And it gives us, as both audiophiles and studio professionals, an opportunity to really ask the hard questions about why do we need this and what difference is it going to make. So, of course, all the marketing material and fluff aside, I'd highly encourage all of you guys to use this opportunity to understand SPL's approach to their products, especially the Matrix, which is their headphone amplifier, and ask the hard questions today about why do we really need this. So what I'm going to start with is asking Hermann and Xavier that, guys, thank you so much for being here with us today.
A pleasure.
And it's a pleasure to be able to have guys like you talking to us directly and to our consumers, our dealers, and share with us your craft and your mastery. And with that, we're going to be talking a little bit about SPL's approach to listening on headphones. And then I will invite Hermann to tell us a little bit about the Matrix and what it does. But to start with, Hermann, let me ask you a question, right? Today, studios see the use of both close field, near field monitors, as well as the use of headphones. Almost every mix at some point of time or the other has to be heard on both. And yet, listening to a mix or listening to music on headphones itself is fundamentally different from listening to them on speakers. So to you, what do you think is the real difference between them? Why do you think headphone listening is a different approach? If you can maybe share with us your thoughts on that to begin with.
Well, the difference is that listening on headphones is an sort of an enclosed listening with two speakers that are close to one ear, and there is no spill from here to the other side. So we're only here at once here and there. It's like an A/B stereo. It's not like when you listen to speakers where they're in the room, you have crossing signals, so you get a mixture of everything in that room with the room acoustics, and that is being perceived by your hearing. So there is a lot more information going on, and because music is mixed for speaker playback, when you put it on headphones, you don't hear it in the same way. One thing, for example, let's take the panorama, where instruments are placed in the stereo field. If they are placed in a range like this in front of the speakers, and you can pinpoint where the individual objects are, and you move them to outward, and you can take the speakers and move them outward as well. Obviously, you spread the whole stereo field and the objects appear wider apart. Now that can lead in a mix to the fact that you would actually perceive the soundstage as almost like it's a bit empty because there is so much room in between. It's unnaturally wide because suddenly you listen to a drummer who has like arms that are 10 meters long and stuff like that. So it doesn't really feel right what you perceive. On the other hand, we have had binaural mixing, and I remember Stux from Japan did that specifically in 80s, 90s, just mixes for headphones. And I can see a similar thing now coming back to us with Dolby Atmos, and the fact that now people like Andrew Schöpf are saying, well, guys, almost 80% of the music is being consumed on headphones these days. So why not go back and mix them on headphones and use the headphone as such and do not care too much about how it sounds on speakers? So it goes the other way. And with Dolby Atmos, obviously, yes, it's there are expensive ways of creating these mixes by having discrete 16-channel speaker playback in a studio, but the listening experience later takes place on headphones, on standard headphones. And so why not mix it directly on the headphones with the help of the Atmos plugins? So there are things that are currently developing and that there are momentarily changing the way people start to approach their mixes. For the fact that we need to have a means to go from speakers to headphones and from headphones to speakers, that is maintaining, because we have those two ways of perceiving sound. And in both ways, the Phonetic Matrix is actually helping you to mimic the speaker playback on cans, and you can also go the other way and create a mix, put it on speakers and see if it works or if it doesn't really work. And I did prepare a little presentation here that I can run you through just to give you an idea on how this matrix actually works, what it does, and what are the parameters that are actually important. I think a general understanding of this is quite helpful. And my journey with this actually started when I was exactly in this room, and I just said this in the first session briefly, and my daughter was born and she slept upstairs, and I couldn't listen to speakers when I was doing my mixes here for my band, and I had to move to headphones, and that's the point where I really understood, Jesus, I sucked at mixing on headphones so badly, and I didn't know anything about how it actually translates. So I started to read a lot about it, and this took me back almost like a journey in time. And there were like in the early 60s already in the Bell Labs, people were trying to emulate speaker playback, and with the help of crossfeed and these parameters, they were experimenting with that, and they were talking about placing the instruments and vocals at the rim, or perceiving them at the rim of your head. That's how they were trying to explain how to bring that sound stage from a total 90 degrees left and right in front of you. And I was then trying to dig a bit deeper where all of this stereo comes from, because we were talking about the standard stereo setup of like 30 degrees angle from the center, left and right. We all know that in hi-fi, 30 degrees. It's the standard speaker setup. So I was like, standard? This is, if there is a standard, then I think there is something written about it. So there is a standard on a paper or whatever, and an AES paper or whatever. And I was trying to find this, couldn't. couldn't find it. So I was I'm one of the professors here on the university. So he's we know us for a long time, and I called him up and I said, "Hey, Dieter, do you know something about a paper that says standard stereo 30 degrees setup?" Because I was looking at the speaker placement, how to mimic this into the matrix. So I wanted to know where this starts and where it came from. And he said, "Oh, that's interesting. That's an interesting question. I never thought about that really." And I dig into it. And then I was talking to some other people, people who own magazines and write for books about this, and the people you know during the course of your life, and say, "Hey, do you know anything about where I can read something about the standard?" Funny enough, turns out nobody knows anything about the standard. They all call it a standard, but there is no standard saying it. So then Dieter called me back and said, "Hey, I found something." And this is from 1942. And it's from Philips Labs in Eindhoven. So that must be right in the middle of the Second World War there. And it's, I don't know, and it's by a guy called De Boer. And I can send you that. Now, luckily I speak Dutch, so I could read that. And it was like huge, but page 80 onwards, he was talking about stereo and the perception of stereo and the setup of speakers. And that was in that respect interesting that he referred to a recording made in 1916, a stereo recording. And I went like, no, where does that come from? And that way he derived that setup, that sort of stereo setup came from that time on the 30 degrees angles. Okay, so I had a presentation to do at the university on the Phonetic Matrix, and there was like an engineer from Sennheiser. And funny enough, he was presenting right before me. He was talking about the early times of microphone recordings, and he suddenly pulled up pictures from a recording made in 1916. And I went like, oh wow, this is going to be interesting. So this is probably it. And it was from Vienna. And what they did back then is they had like a little chamber orchestra sitting in the back. And then there was this, they had a carpet in front of it. And they had two microphones standing almost like 3 meters apart, almost like as we know it from a Decca tree these days. And they recorded it like this. They had like just these microphones, and they had the two hearing devices on the other side. There was just an amplifier or something in between, not really an amplifier because they didn't have that at the time. And people were standing behind that carpet and holding these earpieces to the head, and they could hear this little chamber orchestra in stereo. And then he was talking about the mathematics behind stereo and how to describe a setup for speakers. Let's say how to describe what happens in a stereo environment. And then it dawned on me that this setup, the standard stereo setup, seems to be just a result of the fact that the easiest math can be applied in an even-sided triangle. And that means that you have 60 degrees everywhere. And that means if we talk about our standard 30 degrees, it's right in front of you, 30 to the left, 30 to the right, 60 degrees. That means all the others have to be 60 degrees, or the one where you sit have to be 60 degrees as well. So that's an even-sided triangle. And in that case, the mathematics are the most simple because you can look at it from either way out of the triangle. There is no difference there. Now that is probably, and I don't know for sure, but it's just my thinking, that is the reason why it became the standard setup, because at the time there was no playback in stereo, and it took decades until that arrived. So, okay, that was the little excursion on this side. let's just jump into the matrix and my little explanation here. So I will share my screen here, and I hope you can see. Can you see this?
Yep.
Yeah.
Okay, so I start this presentation. All right. So Phonetic Matrix. Now, this is the very first product that we made in 2008. Some call it the SpongeBob design, which I like. And in 2012, we came up with the Phonetic 2. This one we're going to go talk about this later a bit, which became sort of the blueprint for all of the hi-fi products that we made in the later years after 2015, 16, 17. We had various models coming out there as well. But for this original Phonetic here, that was the result of the sessions here in the studio where we worked on it and tried to figure out how can we actually create mixes on headphones that translate to playback on speakers. Now, so this is in short term what it actually does. The Phonetic Matrix makes listening on headphones sound like listening on speakers. So, and how does it do that? Now, when we take a look at the playback from speakers, then there is a direct line that hits the right channel, hits the right ear, but there is also a crossing signal that goes to the other side. And this crossing signal is slightly time delayed, as we can see. It is lower in level because it is not direct, so it has to be lower. And it has a reduced frequency range. And that is because it travels around your head. And there are certain frequencies that bounce off the forehead. So there needs to be a frequency correction as well. So when you listen on headphones, then you're completely shielded and there is no audio traveling from the one side to the other. So everything that is designed in the mixing process to create that stereo image in front of you is being sort of lost in that process when listening to headphones. Now, there are certain downsides that come with that. We already spoke about the unnatural super stereo effect. That's because you move a speaker from here further outward and place it to your head. That's the super stereo effect. What does that give you? It always gives you an exaggerated reverb and also exaggerated delays. Why is that? Reverb and delays are always recorded out of phase. That is a standard, and it helps them to not mesh up with the in-phase signals. So there are 180 degrees phase reversed. Now you move the speaker from 30 degrees to 90 degrees. That means you spread the angle from 60 to 180 degrees. By spreading this angle on the listening, you also change the phase response and you widen that up, and that makes you hear everything that is recorded out of phase, like reverb, louder. So hi-fi people sometimes say, oh, I like this because everything is so big and so huge. And yeah, that's all that, because you hear all of the reverb so much louder. And that is then perceived as better, but you will see over time, it's ear fatiguing as well. So, and it doesn't fit the mix. And I'm always looking at from it and the standpoint, I want to mix on headphones and then switch to speakers. And it's everything I hear there is exactly what I hear on headphones. So I can work, I can finish a project on headphones while I'm on the road or whatever, where I am, I can work. That was the idea behind the Matrix. Now, obviously, when you spread the front stage, you also have a less focused phantom center right in front of you. So that is being spread out as well. And one effect that we always see is that you have too much bass content on the sides. And this actually is more a problem when you go back to listening to speakers. So you say you mix on cans, you don't have a matrix, you just do it as I did it before we worked with that and invented all of the parameters. I always said the problem that I was like panning my guitars left and right and my synths, and oh, this is nice, this is fat, I like that sound. Next day I drove to work, put the CD in the car, listened to it, and it was all thin and MIDI, mid-range sounding. And I was like, what? I couldn't get hold of that effect. So you lose so much bass content when you move it to the front. That's also an issue. Now, the Phonetic Matrix will help you correct all of these issues. Now, how do we actually achieve that?
ऐप रीडर उसमें आप पेज की फोटो खींचो आपको रीड करके सुनाता है ना
आइडिया नहीं
ये आता है इसका ऐप मैंने
You'll have to mute Xavier if you can. You can mute the participants.
Sorry, guys. Am I on, or I was just confused? All right. Okay. Now this is looking a bit like it's not as tough as it looks. So we have a playback, or we just focus on the right channel on this part, right? So on a standard headphone playback, you have 100% to the right and 100% to the left. With the crossfeed engaged and the crossfeed set to maximum on our units, playback curve would actually look like this. That means that here in the lower range, there is a mixture of about 70 to 30% of the crossing signals, which is shown here by the 30% that you see here in the little green line. And the higher the frequency, the more content only from the right side will reach your ear. Now let's take a look at this a little bit more in detail. Let's take a look at the low frequencies. So below 500 hertz, we already said there is a 70 to 30% crossing. And this is what is referred to as the interaural level difference. If you ever Google this, this is what it's all about, interaural level difference. In the mid-range, between about 500 and 10K, the crossing is getting weaker and weaker. And that is also, that is because of the reflections of your forehead. So the higher the frequencies, the more they are bounced off and they don't reach the other ears. So what remains is only the direct signal. And above 10K, there is no crossing anymore. So that is what crossfeed does. And we have always 6 in the hi-fi world, 4, but no, also 6, sorry, also 6 settings in both hi-fi and pro to select the amount of crossing. Now we're going to take a look at the angle, at the speaker setup. How do you place your speakers? And this is referred to as interaural time difference. Now here we are with our speaker setup in the room, and you may have speakers very close. That could be a setup where you have like a monitor in front of you with 2 near field speakers, and they would just be like 20 degrees apart. Now that would equivalent to 150 microseconds delay. Now that is so small that it's actually not perceived as a delay, and those who are mixing, they all know like a real delay. We talk about that when we are at 17 milliseconds. So that's a lot more than microseconds. But nonetheless, the milliseconds is something that our hearing is actually really noticing. And to just tell you how fine everybody, we all can hear a movement in front of you, is that you can actually hear a change from that center position to like 3 degrees to one side. You would already hear that. That's how fine we hear. So 20 is already 6-fold, more than 6-fold what we can perceive as a minimum event. And 30 degrees, it goes from 150 to 250 microseconds. At 40 degrees, it's 350 microseconds, and at 55 degrees, it's 490 microseconds. On the Pro products, we also have like 15 degrees, and we have 75 degrees. The 75 degrees people use that in OB vans, so where they have like sitting flat to a wall in a truck and the speakers are pretty wide apart. Then to mimic this, you would need more than 55. And the 15%, we use that in Pro exactly also for the fact that people are working in very dense environments on trade shows, whatever, when they prepare shows for being played out back outside. They only have a little screen, 2 speakers in front of them, and that would be mimicked by an even closer setup of speakers with 15 degrees angle. So now we have this, the speaker angle, and we have the crossfeed, and with the help of these two, we can create the crossing signals perfectly, and the problems that are associated with headphone listening are pretty much erased. So that's actually it. On the Phonitor itself, on the Phonitor 2, which is our top model for the Pro side, you see there is another parameter here, and that is the center level. And that is something that you don't find in the literature. Everybody's talking about these 2 parameters that are important, but we figured out when we were using it that as I wrote it down here, it corrects the in-head phantom center loudness perception, which is slightly louder than the speaker phantom center loudness. So that means you diminish the speaker phantom here on your headphones slightly, so that when you put them on speaker, it is equal loud. And it turns out that it wasn't just we who heard this. I now know from most of other users and mixers, their beloved settings are here between -1.2 and -0.1 dB. So we're just talking about a dB about. That's just it. But it's necessary to really get a perfect rendition of your headphone mix, so that it really translates to speakers. Right, so what is the Phonetic Matrix? Yes, it is a pure analog circuitry, and it all uses our 120 volt rail technology, and I introduced that in session number 1. We don't need, and we don't have any ADDA conversion in there. We don't have any signal processing. It's all real-time, full range audio, maximum headroom, maximum dynamics. So we maintain the original sound quality and frequency bandwidths and resolution of any kind of file, because it all stays in the analog domain. And if you like to listen to this on the head and on the website, we do have a video that looks like this, and you can literally hear in that video how a crossing signal from would actually sound like. So we're taking the audio sections apart, and we let you hear all of these individual things that actually happen. It's quite interesting, but remember, wear headphones when you listen to that. It doesn't work on speakers, obviously. Okay, so that is my little presentation here, and let me just stop it right now. If we have any questions for that.
Thank you so much for the presentation, Hermann. I really appreciate it, and I love the simplicity with which you explain that. And to start off, just so that we can get everybody's muscles going, really, I wanted to start off with a very simple question. I can see why audiophiles would really get excited at this idea, because when we're listening to music on headphones, we're trying to replicate the closest possible experience to what music sounded like in the studio, right? That's quite literally the holy grail, or the goal, so to say, for all audiophiles, right? And it's so beautifully explained when you say that, hey, the time delay, the angle is what is going to give you a very different sound on a headphone as compared to what left from the studio on a pair of stereo speakers. That I think should be a great motivation for a lot of audiophiles. But in the studio world, one of the reasons why we ask, or why a lot of engineers like to listen to the headphones, listen to the mixes on headphones, is because they're trying to mix for what the audience, who's only going to be listening to the music on headphones, on a pair of AirPods or a pair of earpods in the subway, and they're trying to listen to what they're listening to. Now, when they're listening to it on the headphones, on the go, in the trains, in the metro, they're not going to be having an SPL Phonetic Matrix with them in their pocket to be able to correct for the crossfeed or the angle. So my question to you really is that it makes a lot of sense when a person's trying to replicate the speaker experience on headphone, but when you're listening to it on headphones itself and you're using a pair of headphones to mix and monitor for that, what would your advice be to the mix engineer? How should he be correcting his mixes when he's doing that?
Yeah, that's actually an interesting question, because as I said before, it sort of shifts right now from speaker listening to headphone listening. I remember that a few years ago we were talking about, hey, now this is the first year that we sell more headphones, or that headphones makes more turnover than speakers in hi-fi. That would happen like 3 or 4 years ago, and now the mixing process is also being revised, and I can see that we're gonna see offerings from engineers who actually create binaural mixes, which are solely used for headphone playback. And I can see that there is probably also some kind of market arising that engineers start to mix exclusively for the playback on headphones. They mix on headphones for playback on headphones, and they utilize the huge soundstage that you have and fill it with instruments, all with Dolby Atmos effects that are giving you a more spatial and immersive experience. So this is going to happen, I think, in the next coming years. And nonetheless, if you do that, you want to see, okay, does my mix still work on speakers? So you can then switch back and listen to, with the use of the matrix, how would that actually sound on speakers? And that is, for example, when you do a lot of spatial stuff, you sort of lose the control over the phase response, and that can be negative on a correlation meter. It still sounds good on cans. Putting it on speakers, you will have certain frequency areas, specific instruments even, erased from the playback or diminished in level so far that they are hard to hear. So the typical thing every engineer does once in a while, press the mono button, flip, and see what remains from your mix. We have these mono features on pretty much all of the headphone amplifiers, so that you can do it immediately there and check for compatibility. Now, my advice, what is my advice? Honestly, it is hard to say, because you need to actually declare a mix a binaural mix. Then it would be the full experience that the mix can deliver to the standard listener on headphones. So it's his binaural mix. If you make a CD and you have like a CD and rip that, and you have that in your iPod or wherever, and take this with you, it will not be binaural, because you will not see binaural stuff being published, neither on vinyl, on CD, or none of these hardware copies. They will probably not do that. So it will be probably similar, as I can see with the detection that some of the headphones Apple is promoting their iPods, that they can automatically detect, oh, there is an Atmos or there is a spatial audio file in the background, so I can use that for the playback. And you have preferences to set in your system, say, okay, I'm going to engage my, if there is a spatial audio mix, take that for my playback as the preference. And I can see that there's going to be a binaural thing coming up. And they're going to say, okay, if they have binaural mixes, then play only the binaural mixes. And we will see different type of mixes, a speaker mix, a binaural mix, a spatial mix. That's probably going to happen. It's going to be interesting. I'm not so sure whether it's going to be, as I know now from a few people I know in the mastering and recording community, they say, well, it's also nice to have all these things, but nobody pays for it. They all expect us to do it on the fly, like pressing a button and here you go. Oh, here's your binaural. Oh, you want binaural? I have my binaural preset. Bam, binaural. And it's not like that. It's a different mix. It's intense, and I can see that those poor guys having to do all this, that they are the ones who are left behind. and I hope that there is enough push from the market side that the record companies actually understand, okay, we're going to put some money into this, and then it is something that I can see as being very positive for the recording community, because they can deliver new formats, and that's always, yeah, giving additional work. And if it's been paid for, that's cool, and we can enjoy it on all of the platforms and medium that we have.
Got it. So it would seem that until we reach a stage where the vast majority of recordings are mixed and mastered for consumption on headphones, that the Phonetic Matrix is going to be an essential tool for anybody who needs to turn his speakers down, but still wants to be able to hear his mixes as close as possible to what he would hear on the on the speakers itself. If I could ask you a couple of more questions about the Phonetic Matrix. Would you be able to walk us through, let's say, for example, how much output power does the headphone output give us, which is, which will give us an indication of, what kind of headphones would be most suitable and compatible to be driven by the Phonetic Matrix? And if you could walk us through some of the inputs and outputs that are there on it.
As you are now talking about like 10 odd products, I can let me just share my screen again, because I don't have all of the numbers for all of the models in my head, but I will take a few examples, and then we can go from there. Let me just share my screen again.
Well, actually, that's just meeting another question that I have here. If we have time, can we go through the other knobs, switches, and controls on the Phonetic 2? So yes, we will.
Yeah, exactly. That's what we're going to do. What we're going to do now, and that will then also answer, the question on the power. Let me just go down here, because I just really want to take a look at it so I can answer this. So you can see here on the jack output on the headphones, we have a very low source impedance of just 0.18 ohms. So that means we can literally drive pretty much any headphone from 12 ohms up to 600 ohms. That's all doable. And our at 600 ohms, at 1% THD, we have 2 times 2.7 watts. And on 250 ohms, it's 2.5 watts. And on 32 ohms, it's now reducing, because that is so low in impedance that you have so much loss in power due to that low impedance. It's 2 times 1 watts. Well, we all know that these are extremely loud headphones anyway, so you don't need that much wattage. If the higher you go in impedance, the more power is actually required to perceive the same loudness. The most efficient is at 250 ohms with 2 times 5 watts. And on the other products that are in hi-fi, where we have balanced headphone output, it's about double the wattage that we run. Okay,
this can be paired almost seamlessly with an, right from a biodynamic DT990 Pro to an Audio-Technica M50X or an Odyssey LCD-X or an LCD MX4, a Hi-Fi Man Aria. These are all easy headphones to be driven by the Phonetic. Simple.
Yeah, we don't have any issues. I mean, we're selling this now for like 9 years, this model, and we don't see any problems. We also have like switch functions, little dip switches, where you can even increase the output level if you have extremely power hungry headphones like Hi-Fi Man, for example, so that you don't have to run your volume here in the maximum area. You can add like up to another 22 dB of output power. So, but this is all because we are running in such a high rail. We have so much reserves in this unit that we can provide for so much power. Okay, I want to run you through all the bells and whistles. The big volume control, well, yeah, solid aluminum, Alps big blue knob, and a remote control, and you can actually remotely control the volume if you so want to. And there is a little video on the learning process with the standard. We don't actually need we don't deliver a remote control, because we thought What? Just another remote control for just the function of making it up and down in level? That's a bit much. And everybody has some remote control infrared lying around, or you have like your big one where you have like two buttons that you usually don't need for anything else. Then you can just teach the unit those two functions. And the video explains you how that's been done. Now, we've been talking about the matrix features. So we have crossfeed angle and the center level. We already spoke about that. And here in the center, there is a little switch that says off. Well, obviously, that switches the matrix, all of this off. All on is to the right side. And to the left side, it is just crossfeed and angle. And that is if you are only using it for playback purposes and you're not in a mixing process. When you mix your own project, you should use the center as well and reduce it to a certain amount. And then you switch this to all. But if you are just listening and enjoying music that's from CD, from vinyl, from tape, from wherever, from streaming, you switch over to a crossfeed angle so that you only have these two parameters. One thing I'd like to add about that's been commonly asked, how do I set this up? How do I know when it's correct? Actually, that is really, really simple. And it's just down to listening. So you take your favorite recording, and I usually focus on the hi-hat, for example. A hi-hat is very easily to distinguish where it sits in the stereo field. Now let's just assume it sits slightly to the right. So you listen to speakers and it's there on the right side. Okay, 45 degrees to the right. Okay, you put your headphones on and they appear much wider outside. So let's say about 70 degrees outside. Then you switch on the matrix and you take your angle and select the degrees that your speakers are actually being placed in your room. That's something you can measure. That's something, well, that's triangulation. Usually you will have it around 30 or 40. And it doesn't have to be so exact. You can play with these two parameters while you are adjusting it to that playback and take one or the other value around the core value that you think your speakers are set. And then you use the crossfeed and bring it in from minimum even further. And you will hear that the hi-hat jumps in. The further you turn this to max, the more this instrument moves to the position where it actually is on speakers. Then you can take your headphones off and it's there on speakers, take headphones on. And if it's there on your headphone as well, done. You don't touch it anymore. That's all you need to do. From there onward, you just use it here, switch it on or off when you need it. You can see here on the rear side, we have like 2 XLR inputs and 1 RCA input. And we have 1 XLR output. That means you can also use this as a preamplifier, and you can go from here to your powered speakers or to power amplifier and use this as a preamp as well, not just like a headphone amplifier. Then you have like the solo switches, solo left and right, phase left and right. You can individually switch this on and off. This output switch over here, this has been used. So you select speaker playback or headphone playback. And if you set it to the center, it is muted and the VUs will the backlit red so that you know, okay, this is muted right now. I can't hear anything. If you go to the left and the right, then it's been backlit yellow. So, and we have one other feature in here that is what we call the laterality. Now, normally people would call this a balance, but I don't like this because balance is about fully left to fully right. And we don't need that. What we need on headphones is we have to compensate for us being human beings with imperfect listening. We all have that, and nobody can say, oh, there's only very few people who have perfect listening. But many of us have a slight difference between how how loud they perceive something from the left or the right side. There is not 100% identical. And in order to compensate this, and because it becomes even more apparent when using headphones, we introduced the laterality potentiometer. So here with the mode switch, in the center, it is stereo, the standard one, mono to the left, and stereo with laterality to the right. And then this control gives you plus and minus 3 dB only. So it's super fine, and it compensates for this little change in hearing for us, and then you can set your perfect position to have everything that is really dead straight in the phantom center, that it appears dead straight in the phantom center, and not slightly left or slightly right from there. Okay, well, we spoke about this at length, and you can see here's that video that I've been talking about. Here, by the way, is that presentation I was just talking to you about. More stuff there. I spoke about the expansion rack last time on the monitor controllers, that you can put this into an expansion rack and add a passive 4-way output for if you have like multiple speakers. And I said that this is probably from the cost performance ratio. It's very good value for the buck if you have this as your monitor controller and headphone controller. So you have everything in one package to drive your studio with multiple speakers, get your headphone, and have a superb 120 volt rail preamplifier. Okay, well, we spoke about this last time. So any more questions on this right now, or shall I run through the other products?
No other questions on my side.
Okay, then go ahead. Oh, no further questions.
No
Sorry. No further questions.
No.
And your questions are, Raghav, I answered your questions on it?
Yes, of course. I'm just very keen to see the hi-fi product, because that's really the stuff that would be of most interest to my audience.
Okay, to your audience. Then let me just jump over here. And for example, our introduction range Phonitor is the Phonitor SE, and it can come with analog digital, with digital inputs as well. Analog is standard. We have 3 digital inputs. If you opt that, it's optional. A standard jack for the output, and we have like the Matrix with 2 presets, crossfeed 1 and crossfeed 2. So there are 2. It correlates with the crossfeed setting on the second and the 4th setting on the crossfeed of the Pro products, and the angle is preset to 30 degrees on this. So, but that's the entry level product, and on the back side it just has analog inputs and the digital inputs if you so want that. The next level is the Phonitor XE. And the Phonitor XE is like the Phonitor 2, not just a headphone amplifier, it's a headphone amplifier and a preamplifier.
That's not the Phonitor XE, that's the Phonitor
sorry.
X.
I just meant the Phonitor X.
Okay, cool.
You're right, sorry.
No problem.
And on here, this product also features balanced outputs. And let me just briefly say something about using the word balanced for this kind of output. Xavier is already smiling because it is wrong.
But I do agree. I smile, but I do agree.
Yeah, it's wrong to call it balanced, guys. I don't know who came up with that, but because balanced it's an XLR connector, so it must be balanced, and balance is like good. In the pro world, we all connect balanced, but we only do that if we have longer cable runs of 3 meters and longer. Then we need balance. If we're just being very close with the devices, then it's not necessary to go balanced, because all that balance does is it gets rid of interference, and that only is caused by longer cable length and things that are introduced into the wiring. So basically, balancing has a balancing transmitter and a balancing receiver, and it receives the positive and the negative waveform, and it then goes to a differential amplifier, and it takes the difference between the two, and everything that is the difference is something that had to be induced on the way, and that is being reduced by what we call the common mode rejection. that is usually like ending up like 6 dB lower in level, or everything that we have but we need a lot of electronics for it. So the audio file, or also I know mastering places like Bernie Grundman's mastering place in Los Angeles, he's doing everything fully unbalanced, because he's saying, I don't want to have all these additional electronics in there. I keep it all to short distance. Now, why is it wrong to call this balanced? Because there is no differential amplifier involved. All that is here is we have plus and minus for the left and plus and minus for the right channel. That's it. It's unbalanced, honestly, 2 times unbalanced. And the benefit of doing it this way is you have more power. That's a good thing, because you need, this stage is actually twice in here. In fact, it is this, for the left and for this channel, the left channel, it uses the same op amp that we use for the standard output. And then we added another one to drive the right channel here on these 2 pins. Now people say that, yeah, but I have more spatiality when I'm listening to a balanced output. That's true. And that is an effect that comes with the fact that you don't have a common ground. A common ground always helps amplitudes and levels to rise pretty much in the same phase, with the same phase. But when that common ground is gone, then the amps work with their own phase. And this change in little phase is like a stereo expander. So you slightly hear more spatiality because of that, but it's an effect. It's not wanted. It's not in the mix. It comes with that kind of technology. Pretty much the same as using 2 mono amps, 2 mono blocks in hi-fi on speakers. Same thing. All right. So, yeah, here, as I said, on the Phonetic 2, we have the same switch here for switching between headphones and speakers. We have the same laterality. I think I come to that later, I guess, in here, in that demo. And on the rear side, yeah, you have like 2 outputs, one that is balanced, one that is unbalanced. And we have amp control outputs. Those are 12-volt trigger outputs. So when you have like an amplifier set up with this and you switch on the Phonetic X and you have these trigger voltages connected, the power amp goes on as well. But it has to have a specific trigger input for that. But it triggers any amps. Our amps do have this input, but there are also third-party amps that have the same input. Yeah, we have the same volume remote control, same thing with the setup. And this is kind of interesting, because this one, I'm just boosting this a bit in size. You can see up here, we have dip switches on the bottom of this unit. And if you switch number 1 on the headphone output, we'll have an additional 22 dB of boost. This is for the super power hungry, or if you're just damn deaf, then you can use this. Be careful. And that's why we put it under the back. You should know what you do when you touch this before you ruin anything. Number 2 on will be like 12 dB plus. Number 3 on, this is for the VU display. Sometimes a VU on where it goes to 0 and you have like full CDs or whatever, full scale digital music. The needle sticks to the right and that doesn't look good. You can't see nothing. So you can swap that reference and get that reference from 0 down to +10. So that means you have 10 dB louder music can also be displayed and the needle is nicely moving. You can switch the XLR or the RCA to become direct outputs if you don't want to have these affected by the volume control. That can be kind of cool when you want to feed this to some other, you have, let's say, in between a series of products and you want to feed this through from an output that you have from the workstation, for example, and you come from here, but you need this output elsewhere, so you can feed this to another headphone amplifier, to another room, whatever you like to do with that. And there is another dip switch in on the back that allows you to, when you switch to headphone listening, it automatically switches off the amplifier to save the power consumption of the headphone amplifier. Right. So this is the Phonetic X and the Phonetic XE, which is this baby, is the best equipped standalone headphone amplifier. This doesn't offer you the preamp functionality. It's just an headphone amplifier. And it is pretty much what you know, what you see from the features, very similar to what you see on the Phonetic X. But here, for example, we have the outputs twice. We have a set of outputs in the front and the same set in the rear. That is just that. I know that audiophiles, they just don't like to have the cable hanging from the front side of the unit. They want to have a clean faceplate. So, right. So you can put it to the back and you switch this to R for rear, and then you don't have the cables in the front. Also, if you do this properly, you don't fall over the cable. It's just a bit safer to put it into the back. Here, we not only can remotely control the volume, we can also remotely control the inputs. So we can switch. Oh no, I'm sorry. No, that was a different product. I'm confused. That was the Director preamplifier that does that, not this one. We have our biggest converter put into the Phonetic XE, and that is the one that also features the AES input, which is the professional SPDIF input. All of these inputs, coax, optical, and AES, they are all SPDIF formats, just different in level, and optical or base wire. The biggest difference of this converter to the ones that we use in the Phonetic SE and in the Phonetic X is that we used our biggest deck, the DEC 768, and that always goes along with what we call the DLP 120. This stands for dual low pass filter in 120 volt rail. And to explain to you why this is important, I need to do a little bit of an excursion here. Every converted chip puts out an analog signal. Let's say a DEC chip. Every DA converter has an analog chip, an analog output at the end. This is what we then use to boost it and to get it in our headphones. But the chip itself puts out the frequencies up to almost the 700 kilohertz and even higher. And above a certain frequency range, it goes up into the megahertz. You have like ripples, and you have rings and all these noises, digital artifacts that sort of translate down, and you start to hear this in the faint in the background at about minus 70 dB above 10K, you start to hear all these ripples. So what is mandatory to be done with any DAC on the planet, there is no exception to this. You need to have a low pass filter. And that low pass filter has a certain roll-off that is usually going along with the sample rate you select. And it's always half the sample rate. Because that is what is being called the Nyquist frequency, and that is the last frequency that can contain information, useful information. Let's say 44.1 that we all know as the standard single sample rate. The Nyquist frequency is 22.05 kilohertz. And this is the last frequency that can be transmitted, because that's the only way where you have like a 0 and a 1. Above that, there is only one, there's no differentiation for a binary signal. So half the sample rate is always the Nyquist frequency. That's where your audio transmission stops. Now, the chipset of the Velvet Sound AK4490 that we use, it's a 32-bit. It goes up to 760. It does DSD, blah blah blah. All that is fine. This chipset also has a technology built in where they always use the highest sample rate, and the Nyquist frequency is always half of that highest sample rate. So we created two low pass filters. That's why it's dual. One for the PCM playback that is about 380 kilohertz, where the Nyquist frequency of that highest 768 kilohertz is positioned, but you cannot use this for DSD playback. DSD is much more problematic in terms of how loud you perceive these artifacts. Although the hi-fi community raves about DSD, the pro community hates DSD. You cannot do anything with this signal. It's a 1-bit signal, and easily spoken, a 0 means I'm more than you before, and a 1 means I'm more, and a 0 means I'm less than the value before. That's it. So it's basically, it was designed in the 90s to archive music and to have a means to go back from an archive to create any sort of PCM version that might be needed in the future. So the idea was from the creators of DSD, what kind of tracing, what kind of signal are we going to introduce and use for archiving that we can then, let's say we now have 44.1, but we may have 192 in the future. Think back, it was 92. And if you would have restored anything back in 44.1, and we're now 20 years to 25 years later, we're like talking about 768, which they never thought about that it would go that high. And I just saw the latest chipset that AKM announces. They go to 1.5 megahertz with the next step. So, and 64-bit, that's their biggest chip they're going to be introducing next year. And so there seems to be there's no ending to it. So the DSD was there to then only capture the surface of the sound. And that is like with 11.2 megahertz, that's super fine, but it only gives the upper curve line of it. So, and that's when you then chop this in pieces, you can create a PCM signal out of a DSD signal again. And that is how DSD came along. And then the hi-fi community thought, oh, that is so brilliant. And Sony and Philips thought, oh, if they think it's so brilliant, yeah, then we're going to make a playback format and we're going to make DSD players. Oh, yeah, and then we have surround. Yeah, great. We're going to make a Blu-ray and we get all on it for like 6-channel DSD or 8-channel DSD and films and everything. It's going to be super. Well, nothing of that really happened and was used. At the end of the day, the players were no longer stereo, were no longer surround. They went back to being stereo DSD players, the latest versions that Denon, Marantz, and Sony put out to the market back in 2005 and 2006 something. So, well, that excursion, we'll stop this here. Now we need to have the DSD playback because it's demanded, but we need to have a lower roll-off frequency. And guess what? Can you imagine where this roll-off frequency actually is? Now you probably don't, and you don't want to know, because it is at about 40 kilohertz. That's where you need to roll off. Otherwise, you hear artifacts you don't want to hear. And I went through this because I didn't believe it, because in the press, oh, I have native DSD playback, native DSD playback. And I said to my designers, I want to hear native DSD playback. And they said, no, you don't. I said, well, yeah, I have to. I need to know. Well, you shouldn't. I said, come on, guys. Yeah, okay, we're going to reprogram this and we're going to let you know how this sounds without a filtering. And it was all that shit in the background, and you go like, is that native? That is native playback. You can't listen to it. Fuck. Sorry, did say that. But where's that frequency? Yeah, it's like 40, 50, maybe sometimes it's 38 kilohertz where you need to roll off. What? So it's like a 96 kilohertz PCM signal. Or an 88.2, so double sample rate of PCM. That is the maximum that we can actually play back with DSD, but we're talking about DSD2 and DSD4 that has like a frequency range of 300, 400 kilohertz. Yeah, but you can't use it. Wow. Just so you know.
I'm going to thank my stars that aren't too many of my customers on today's webinar. Otherwise, my phone would go off the hook with all of them wanting refunds on their expensive balanced outputs, their balanced cables, and their DSD compatible DACs.
Yeah. It's just so we need to know what the truth is. So we can believe marketing as long as we want, but it's just believing somebody saying something. And we're here to do some masterclasses. We're here to talk about what is really going on, and we should know. So,
and it's also of interest to a lot of people who, want DACs with AKM chipsets, because there simply aren't any available to any other manufacturers today. So SPL would probably be one of the rare manufacturers that can have an AKM chipset in their DACs, because you simply can't get your hands on one anywhere else because of the factory fire that they had.
That's actually true, and that is giving us a huge headache. And we've been putting a lot of money down to procure the models that we actually need. And I've been presented an internal paper from AKM, and it looks like they are going to be back in business next May. Our reserves will take us that long, so we're pretty much on the safe side. But the chip crisis is currently that we have is not created by those companies that produce the wafers, but by those companies producing the packaging or making the packaging, package the wafers into all sorts of different sizes of chips and pins and stuff like that. So that is out of the hands of AKM. So nothing is really sure right now. So it's a bit of a struggle, and many of the companies have, after they knew about the fire which happened last year in October, that they were like going away, and then you realize that pretty much all of the other manufacturers, be it Burr and Brown from like Texas, or be it Analog Devices or Crystal, or they all stopped at 192 kilohertz. And they literally didn't develop anything since 2012. And the only company that did something was ESS with the Sabre chipset. But they actually mainly developed this for car playback and for multimedia playback. So they don't have an ADC, they only have DACs. But the downside with them is that they have so much filtering and stuff going on that you cannot really switch off, that they are that you cannot, from a pro side, you cannot word clock them because they don't accept the word clock, although they say they do, but they don't. They just see, oh, I get 44.1, then I switch to 44.1, but they don't sync. They take their own internal clock after they realize what clock has been present. And in a professional environment, that's a no-go. Nonetheless, it's been, I know pro companies that have been starting to use these chips, and we were happy that we could procure so many chips for us that we said, okay, we're gonna go through this and just wait it out and hope that they come back before, because we would end up with a lesser quality. And that's the least thing we wanted. And we don't want to go sell the lesser quality for better just because the marketing department needs that information. That wasn't our drill either. Okay, well, already, hey, Xavier, right? I'm waffling too much. So
no, you're just being Herman.
Yeah, I'm sorry, guys. I'm just usually taking a bit far. To finish this off, I'm just, I don't know if that's even of interest. Do you want to see the products that have the headphones and the Phonetic Matrix built in, or is that something that you could look up yourself? Otherwise, I'm open for questions, whatever you might want to ask.
I think let's take a couple of questions. We've got a couple of different questions which are coming in, and I'd invite the participants to use the chat box to ask the questions or raise their hand in case they want to speak up. One of the questions that, of course, people are asking is that in the modern environment, with more and more people using cheap Bluetooth headphones and AirPods and things like that to listen to music, how does the mixing environment change? What kind of hardware would you change with it, and how will the Phonetic adapt? I think you addressed that a little bit in the beginning of today's presentation when we spoke about that. But would you maybe want to address that in a little bit more detail and maybe offer people some perspective on how mixes will change and how people would use headphones differently to mix the products, with Bluetooth headphones and AirPods becoming a popular listening medium?
Yeah. obviously the pro community will not use Bluetooth headphones. That's just simply to the fact that you have like a stream that is data compressed, and and we all know that this in the pro environment that would be like listening through a bad MP3 and as on your main monitors. You will not do this. For playback and convenience and using it wherever you are, that's a different thing. But at that point, well, if you have a Bluetooth headphone where then the power is built in to the headphone, there is nowhere where we interfere with any kind of technology, because that is where everything happens inside the headphone. The power amplifier is in there, the Bluetooth receiver is in there. Yeah, and you have and the battery and all of that is all being packed into the Bluetooth headphone. So that's in sort of an isolated sphere, or where you cannot. I mean, you would literally have to send a signal via Bluetooth that is prepared with the crossfeed, which you can do that. You can actually send a signal with this information to a Bluetooth headset, but I don't see that's going to happen. This is not be no. Yeah.
Okay. Any more questions that we've got from today's audience?
Yeah, I have one question.
All right.
I was wondering, how is the Phonetic Matrix different from, say, a software like Dear VR or Dear Monitor, which plug-in Alliance and both Dear VR themselves actually promote? I mean, I keep getting offers. I did try their two-week demo. When you put on the Masterclass, my only concern was actually you can't really record with that, because the latency that it introduces, that just that didn't suit my workflow.
Yeah, that is because they're. I mean, the Dear Reality guys, they. I actually know the two boys. Well, before they sold their company to Sennheiser, and they actually demoed the VR at our company, and they were looking for an opinion on where they were. That was right very much in the beginning of their company. Very intelligent people, and their design, their main design was being offered an environment on headphones where you can move around in virtual 3D environments with head tracking. That was part of the system still, I guess. I think it was, but so that you can actually have immersive audio experiences and you move around and everything in the room moves with you. Or let's say it doesn't move with you, it stays in the area where you are and you move around, and the sound stage remains in the same position. Honestly, I never understood this, because the fact why pro people, and I consider myself coming from that area, I take headphones on, and when I work with my rack and I fiddle with compressors, EQs, whatever, if I would take a headphone on and it's head tracked to my location there, I couldn't even judge what I'm doing. So I'm happy that it actually doesn't do that, and it stays where it is, and it's just a straight stereo like that, and it remains straight stereo while I'm doing it, so I can judge what I'm doing. So, but this is a different thinking. It's about gaming. It's about artificial spaces. You have that in games more than in music. Music doesn't contain this information. Now, the difference also is that they don't really mimic the stereo playback like we do, because the interaural level and interaural time differences for them is not what they are after. They are after an artificial room experience. So it's totally different. And those mixes that you create on it, they might work for immersive audio playback situations, and that's where they're going to be used for in the future, but not so much for anything stereo. At least I can't see it, but I'm not really an expert on that field. No, it's.
But if I can maybe make it into a broader question, in case people are shy to ask the question, but why can't we do the same kind of crossfeed emulation on DSP rather than doing it through the hardware of the amplifier? if you can answer that question briefly.
Yeah, briefly, you can obviously, and to be honest with you, I'm working on a plugin right now with Plugin Alliance to create this as close as possible. Yes, that's something that we also want to offer in our portfolio. The thing is, and that applies for our own plugin. Then it is digital. It takes time. It is resolution. We were talking about resolution. We're currently not 100% sure how it will translate, and especially on the interaural time difference, where we talk little microsecond differences, how well that is being represented in standard sample rates. So we have resolution things to tackle, and we maybe have to do oversampling stuff, blah blah blah, to actually accommodate for this, and that has to yet be explored. That also means that we go through resolution issues with that. That depends on the project you've been using, and usually in the pro world, nobody is using really much more than 88.2 in the audio world. Let's say 96 if video is going along with it, but 192 is already very rare. On multi-channel projects, I don't see that. Then 88.2 is pretty much the maximum. So that is definitely bringing down the possible resolution. And then we're using analog filters with 120 volt rail. That dynamics is a different thing. You cannot really get the same dynamic response out of a digital emulation. So these kind of things will affect it. Nonetheless, I hope that at the end of the work, we'll have a product where you can use any headphones, and you have that plugin in your monitoring chain, in the digital monitoring chain. You run it through a deck, and you can work with that or enjoy music with that. That's at least the goal. Yes.
Understood.
The other question I had was, so you mentioned that reverb is always out of phase normally. Now, when you use the Phonetic Matrix, now, can you elaborate on that particular aspect? How does that change?
Well, I don't think it's going to change much, because it is that reverbs are recorded out of phase is always the same procedure, and it will behave the same way as it does now. I don't see that there is going to be any.
So it's just that you're able to accurately perceive it with the monitor, with the monitor better. Is that what you meant?
You mean when you use the matrix on?
Yes.
Yeah, the thing is that we need to combat the fact that we hear more of the reverbs when we spread the image of the when we spread the bass of the playback speakers. That's and so the headphones, which are 90 degrees left and right. If you spread it so far, you just perceive more of the out of phase signals, and we need to, if we don't want that, we need to shrink this, and that is part of the crossfeed that does that.
The crossfeed process. Okay.
Yeah.
Thanks, Tom.
All right. I don't have any other written questions on my side. Did we? Is it crystal clear for everyone?
Yeah, it sounds like a great product.
Looks so.
Yeah.
Okay,
Hermann,
if there aren't any more questions, I'm going to thank Hermann for today's presentation. I think it was a lot of fun. I think we really got to understand the thought process with which you approach the matrix. It allowed us to really go deep into the product and understand why it's essential that somebody would have a product like this if they intend to mix something on their headphones, to be able to get it close to what the monitors in the studio are giving you, and all the various corrections which are required when you're switching between the two. The hi-fi products are, of course, a lot of fun to see, because I can see a lot of people wanting to get better imaging, correcting for that super stereo stuff that you get on their headphones. So it's a lot of fun for the audiophiles as well. And it's a lot of fun to hear your opinion on balanced output, on DSD, and all the fun stuff that we did over there as well. With that, I really want to thank you on behalf of all of us here in India for conducting this masterclass. I know I learned a lot of things over here. And if there are any other thoughts, Vivin, that you want to give us before we close?
Stay safe. Happy Christmas.
Vivin, your mic is out. Your mic is off. Right.
Sorry,
No
I was
problem.
on mute. Yeah, so I guess between both of you, I think you've addressed a lot of things, and it was indeed a lot of fun. Thank you so much, Herman. Thank you so much, Raghav.
Welcome.
Yes, thanks,
thank you
Raghav.
for this. Yeah, and I think we will meet next in January.
Yeah, the next one is going to be on the 12th of January. So it's going to be the regular Wednesday, same time, same place. And it's going to be about the transcripts and the mic preamps. So
absolutely. And hopefully by then we should have the products in-house, in which case I can actually show you the product. It should be with us. And Raghav, thank you. And I will make sure to send the Phoneter out to you. You must try it. And I'm guessing you already have tried it. Have you? Have you tried the Phoneter before?
The older generation, yes.
Oh, the older generation one. Okay, cool. So I'll make it a point to send one out to you for you to do your thing with it. All right. Cool. So thank you, everybody. And wish you all a lovely holiday season, a Merry Christmas, and an advanced New Year wish to all of you.
Yeah, same from me. Stay safe, everybody.
Yeah, stay safe. See you next year.
Thank you.
Yo, bye-bye.
Bye. Bye. Cheers.